Reading code is the quickest way to get better at coding, yet it's the most underrated developer skills. In this video, I will show you how to learn new coding skills faster by diving deep into the code base of a famous open source library. But rather than painstakingly figure out this code base, what I'll do is I'll walk you through how I walked through this code base in just 10 days using AI. The library we're going to be taking a look at today is the TanStack Query library. And I'm just going to jump in and introduce you to what this library does in case you're not familiar with it. Now, this is a TanStack Query website, and you can see that it describes itself as a powerful asynchronous state manager. To understand what an asynchronous state manager is, you need to understand what a synchronous state manager is. If you've used frameworks like React, you know that React has a state tracker function called useState, and that state function takes some form of data and keeps track of the changes in that data and gives you back the data when you need it. Now, the data that's being tracked inside useState is generally predictable. It's data you create inside your app and then manipulate that data and grab that data back. Now, asynchronous data is different. You don't create asynchronous data or asynchronous state in your app. They are data that comes from outside sources, usually through a side effect. And the problem with those kind of data is that sometimes they are not optimal. You might want to cache that data so that you can reuse the data. And this is where TanStack Query comes in. What TanStack Query does, for instance, is let's say you have an app that has a tab, and for each tab, you want to render a component, the same component in each of those tabs. That component is always going to fetch some data whenever it's rendered. That means that whenever the user switches through the tabs, what's going to happen is that you're going to keep refetching that data. So what you want to do is find a way to cache that data so when a user quickly switches between tabs, they are going to be presented with a previous or a cached data, and this is exactly where TanStack Query comes in. As long as that data is not stale, as long as it's between a cache window, you are always going to get the data that was cached, which gives you or gives your user an optimal experience. That is TanStack Query in a nutshell. Let's see if we can jump in and see what it takes to get started with this library. From the landing page here, or from the TanStack Query homepage, what I can do is click on the Read the Docs button and then click on Quick Start. And you can see that what's going on here, we're importing a few items from the React Query library. And then we wrap our parent component with a provider that takes a client. And that client is we're going to create a client using the query client class. Then finally, we pass that client to the client property on the query client provider. Inside any component that is a child of this to-dos parent, including the component itself, what we can do is call the useQuery function. And this is what we're going to use to fetch some data. What this function takes is one, the query function, which is what it's going to use to fetch the data. This is usually a function that wraps a fetch function. And then secondly, it's going to take the query key. And this is what it uses to identify this query in the cache. So whenever it caches a query, it uses the query key to know how to find that query or how to find the data that this query returns when we need to fetch this data again and the cache is not stale yet. And that's pretty much the fundamental of getting started with TanStack Query. Now let's actually jump in and take a look at the code base and see what we can do with the code base. Before we dive deep into this code base, I'm going to give you two tools that's going to make your life easier when it comes to reading large code bases. Not just TanStack Query code bases, but code bases that you find interesting or the ones you have to deal with at work. Alright, now the first step in this framework is to understand the architectural overview of the project you're dealing with. I don't want you to care about this simple or the minute stuff about this project. I just want you to focus on the components that are put together to make up this project, or the layers that are put together to make up this project. Nothing special, nothing deeper than that. Just components, layers, and how do they come together to make up this project. Now, the second step is to find the patterns that are in this project. Again, just like the first step, I want you to focus on the big picture stuff, not the detailed patterns that might be introduced to this project. What I want you to do is prioritize the top 3 patterns that are very common that you can see that this project is using, because there's a chance the project is using a common pattern. And this is where AI comes in really handy. What we can do is ask AI to find this pattern for us, walk through the code base and find some of those common patterns for us. Moving on, things are about to get interesting now. The third step is to find the entry point of this project. And this was why at the beginning of this video, I made sure I showed you the getting started page of TanStack Query. The reason why I did that is there's a chance the creator has a fundamental way for you to use a library. In this case, the creator of TanStack Query wanted you to know how to use the use query first before you do any other thing. And that was why we had to start there, which means there's a high chance that use query is going to be our entry point. All right, the fourth step is going to be to find the execution path from that entry point. So once you've found the entry point, what you want to do is set up a debugger to walk through the code base from that entry point to the point where I usually say where the rubber meets the road, which just means that we want to take out all the abstraction and see what is the actual problem that this project is solving? What's the actual solution that this library is providing us if we remove all the abstraction noise and just focus on A to B? And finally, to the fifth step, what I want you to do is to understand the algorithm that is available in that execution path. So let's say you've walked through the code base the first time, and now you know that there are some lines of code you don't understand. What's the algorithm behind a line of code? This is where AI gets really powerful. You can just, whether it's Cursor or Windsurf, select VS Code as well, select a line or a block of code and ask it to explain what's going on there. That's pretty much everything you need to know about the framework. Now let's take a look at the second tool, which is to understand how to prompt AI properly. And for that, I'm going to jump back into my code editor here so we can walk you through my Windsurf rules file. By the way, I'm using Windsurf, but Cursor works as well. I think VS Code should do a good job as well. And what I'm doing here is I'm starting this rules file by setting the goals, setting the big picture goal for the AI to understand. And that is that I would like to improve my coding skills by reading the code written by professionals. It's a very simple one-line statement that sets the direction of this project or of this exploration. And then once I've done that, I then go ahead and make sure that I make my framework available to the AI so it uses this framework. And I'm doing that with a few points here. I'm starting with stating the fact that I want to understand the architectural overview. I want to locate the entry point. I want to debug. I want to understand the abstractions. I want to understand the integration points. I want to understand the principles and patterns. That's the second step in the framework. I want to understand the algorithms. And I want to learn the relationship between the actual code and the big picture stuff, the architecture. Now at this point, we've gotten all of the framework stuff out of the way. Now let's discuss what my response template looks like or how I want the AI to respond. Now, first of all, I'm starting by saying that I want the AI to let me know that it's considering the rules. The reason why I'm doing this is when I'm using Cursor, because sometimes I share this file between Windsurf and Cursor. And what happens when I'm using Cursor is that Cursor tends to skip my Cursor rules, which is why I'm making sure that if it ever does that, I'm aware of that fact. Then secondly, I want to make sure that every single time it gives me a response, I want to make sure that it ends that response with possible next steps I can take in case I'm out of ideas on how I can dig deeper into the code base. And now we can move on to the last section of the rules files, which is the actual template. Now, let's say I've selected a block of code or a line of code I don't understand and ask a question. What I want to do is, one, I want it to make sure that it lets me know if this is a common pattern. And secondly, I want it to let me know the purpose of this line of code or block of code and what happens if this line of code doesn't exist or is removed from this project. Then I also want to let me know the implementation details, which is just the algorithm. I also want to understand how this line of code or block of code fits into the big architecture of this project. Then finally, I want to let me know how to test this line of code or block of code, or what test I should run in the test file that would cover this line of code or block of code, just to help me understand how I can actually execute this line of code to see how it works in context. Now, at this point, we've taken care of all of the boring but important concepts. Now we need to dive in and actually see how we can walk through this TanStack Query code base. Let's jump in. All right, so I'm going to start with figuring out the architectural overview of this project, which is the first step in the framework. And what I've done here is ask Windsurf, or specifically Claude here, The question I'm asking is, what is the architectural overview of this project? It's just that simple. And it goes ahead to analyze this project, read through the entire code base. And if we just skip down, leave all of the pattern and purpose stuff for now. If we skip down to the architectural overview, you can see that it did a brilliant job. Windsurf has done a brilliant job to figure out what the structure of this code base is, what's the architecture of this code base. And it knows that one, we have a core layer which contains all of the shared code that TanStack Query has. Then secondly, it knows that there's a framework layer, which is where all the adapters live in. The adapter for React, the adapter for Svelte, Vue, Angular, and so on. And then he also knows that there is a developer tools, which if you've used TanStack Query, you would know about this, but we don't care about both the dev tool stuff and the persistence layer stuff. What we need to know is that we have the core layer, which is where all the features are shared in TanStack Query lives. And then we have the framework layer, which is where all the adapters for all the frameworks live. And with that in mind, what we need to do is move on to the next step to understand what the patterns in this project are. All right, now for the pattern, what I'm asking Windsurf here is, what are the top 5 patterns that are being used in this project? And you can see that, again, just like the previous question, he did a great job. He knows that this project uses the observer pattern. By the way, if you want to learn the observer pattern thoroughly, this is the code base to read, because TanStack Query did a generous job at using this pattern. But by the way, or anyways, he also uses the factory pattern, the singleton pattern, the proxy pattern, and the state machine pattern. I don't know about the 4th and 5th one, but I know that there is a lot of observer pattern in this project, and then there's the factory and singleton pattern as well in this project. Beautiful. Now, once we understand the patterns, we understand the architectural overview. Now, the next step is to understand what the entry point for this project is. Again, we already have a clue. We went to the getting started section of the documentation and we saw how to fundamentally use this product or this library, how the creator wants us to use this library. That's the insight we're going to use. And we also know that the project or the architectural overview section, when we had the conversation with Windsurf, we know that we have the core layer. It should be this way. we have the core layer, and then we have the framework layer. Now we have to figure out which of these layers we want to get into the code from. Now the intuitive thing to do might be to get into the code from the core layer, which is the most natural thing to do. You want to start from the start. You want to start from the ground. But I would suggest something different. I would suggest that what you do instead is look at any code base from the perspective of the client, from the perspective of who is using that code base. The client in this case is you, the developer, who is going to end up consuming TanStack Query. How are you going to use it? What I'm going to do is I'm going to go to that getting started page. I am going to call use query to fetch some data. And that is the insight we're looking for. That is the clue we're looking for to understand what might be the best way to start testing this project. So let's find how to get into use query using AI. Now, what I've done here is that I've asked the AI to find the entry point for the React query adapter. You can see I'm being very specific here because I'm a React developer. I understand React better. You might be a Vue developer and you want to look at this code base from the Vue perspective. You have to be specific with that because it could give you all the options. Or if you're actually not specific, maybe it might give you all the options. But in this case, I wanted to just make sure that I'm reading this code base from the React query angle or from the React query perspective. And again, it does a great job. It gives me 2 ways I can get into this code base, either from the query client provider, which we saw in the getting started page, or from the use query hook or any of the other hooks. And I think for me, I would prefer to look at this code base from the use query hook because it's an API I know thoroughly from using the library in a client code. Okay, I think it's time for us to have some fun now. Let's actually go ahead and dive deep into this code base. We've been just preparing ourselves for this point in time. So let's actually see what this code does. Now, I'm not going to see the entire of TanStack Query code base in just one video, but the tools I'm going to give you right now, it's going to make it easier for you to dive deeper on your own spare time, or if you want to do that for any other code base. So let's jump in. Now, the last question I'm asking the AI here is, since the entry point is query.ts file, I would like to, 1, find the tests for this file, and secondly, set up the VS Code debugger to debug those tests. And it does a great job to find for me, or to share with me, that there are two potential test files for this project. We have usequery.test.tsx and usequery.promise.test.tsx. We are just going to focus on the first one for now. When you open this file, by the way, I haven't shown you the usequery file, so let's just search for that. And if you search for usequery, you should see that there are different potential usequery here. There is Vue usequery, there is React usequery, and there should be maybe other libraries. No, okay, just Vue and React. In this case, we just want to make sure that we'll go into the React one, and this is what we want to test here. All right, now we're going to come back to this function in a minute, but for now, let's jump back to the test file and see how we can debug this test. You could use the VS Code debugger. You can see from the response from Windsurf or Claude, to be specific, you can just set up a launch.json file using this config, and you should be good to go. But I'm going to use my favorite debugger, which is Wallaby. If you're using Wallaby, what you need to do is to make sure that this project is ready to run locally. And to do that, we need to first of all open the contributing.md file. Let me make sure that we're looking at, the rendered version. All right, we need to make sure that first of all, we run pnpm install to install all the dependencies, and then we need to run pnpm build to build this project. And the reason why we have to do that is because this is a monorepo, and what that means is some of the packages that depend on each other are yet to actually get compiled and moved to those packages that depend on them. So let's say if React Query depends on Query Core, when you run pnpm build, that's going to build the core library and then import that core library into the React Query folder so you can access it from there. That's the reason why you're doing this. You're not building it for production, you're just building it so you can actually test it or use it locally. All right, now the next step is to actually set up Wallaby. And to do that, what we need to do is open the command palette and choose Wallaby select configuration, then choose custom directory. What I want to do here is to go to the packages folder and select React Query. The reason why I'm doing this is, again, the TanStack Query folder is a monorepo, which means that there are packages that are inside this folder that have their own root or entry points. So I want to make sure that the perspective of Wallaby is just React Query. We don't want to test any other thing, even the core, just React Query. All right, now once we've done that, we can close out and then open the test one more time. So I'm going to go to usequery.test.tsx. Brilliant. Now the next thing we need to do is make sure that Wallaby is running, and you can tell that it's running because we have these green squares in VS Code Gutter that shows that this particular line of code or these blocks of code are being covered by this execution path. But if you want to run Wallaby, all you need to do is open the command palette one more time and run Wallaby smart start. This is going to, the smart there just means that it's going to only run when a test file is open, and it's going to run that test file. This optimizes Wallaby so it doesn't take up a lot of your CPU. And you can see that if you give it a few minutes or seconds here, rather, it's going to run through the tests inside this open file, and it's going to show those green squares one more time. Fantastic. Now let's move on. Let's find a test file that actually calls useQuery, the useQuery function. And to do that, all we need to do is search for useQuery. And you can see that we'll have one inside this first test suite. But the problem with using or debugging this test is that it doesn't, this execution process doesn't cover this component. So we can collapse this test suite and look for another one. Now if we scroll down, just want to keep going until I see useQuery being called in a test that actually has some green squares on the side. Perfect. This one should work. As you can see, this test actually covers this line of code, which is where useQuery is called, which tells us that this is definitely going to call this function, and we can use this execution path to find out how useQuery works. And to do that, what we need to do is click the debug function above the test, and then we can start stepping into this execution path. Now I'm going to keep stepping until I get to the point where we get to useQuery. Now for the purpose of just focusing on useQuery, please ignore every other step it takes to get to this point. So I'm going to skip step in, move faster until I get to this point in time. This is what we care about. And once we step in one more time, you can see that we are into the use query function now, and we can start understanding how this function works. This is the only function we want to test in isolation, and let's jump in and take a look at how this function works. All right, now at this point, we've found a way to run this code. We've found a way to execute this use query function. And not just have we done that, we've found a way to run it and also pause it halfway so we can inspect the data that flows in and out of this function. Now, the next step is actually to step through this function and understand how it works. Before we do that, I have just one more thing to share with you. While you're stepping through any code base, not just in this case, I want you to focus on the data that flows in and out of that function, and don't worry about the dependencies. So what we're going to do is we just want to focus on what does the use query take, which we know is options and the query client. But then what would it produce after it takes those arguments? What is going to be the output after it takes those arguments? That's the only thing we're going to care about. Now, with that in mind, let's step into this function. Now, we already know that, or we can already see that this function depends, or it's basically executing a use-based query function. So what I want to do is step into this function. I'm going to just step away from these checks, because what's happening here is that we're just making sure that the type of option is object. We just want to make sure that you provide the correct argument to this function. All right, now this is where it gets interesting. Let's look at the first thing that this function is doing. Again, I told you, remember, to not worry about the dependencies. We just want to focus on the data going in and out of this function. That is what testing is all about. Dependencies, we can always test them in isolation. We can go again, like we did, find the query or ask the AI to give us the text that covers use query client, and then we can test that client, this function, in isolation, not in this case. So we won't step into this function. What we would do is step over this function, and then would inspect the data that's going in and out of this function, of the use query client function. So let's step over it, and then we can inspect query client. If we run the command, if we open the command palette one more time and choose show value, you can see that it's undefined. And the reason why it's undefined is because the query client argument, which we get from use query, is actually optional. So in this case, it wasn't supplied, which means that if the creator is expecting it to be undefined, somehow this function knows how to handle when query client is undefined. Now let's see what the value of the output is. So if we inspect the output, we can see that it's a query client object. That is the only thing we need to care about. Then we can move on. All right, now let's see what is the output of use is restoring. It doesn't take any argument. It just produces an output. So let's inspect again, and we can see that the output is false. We know that use query client gives us a query client object, is restoring gives us a boolean. We don't care about all the things that these functions are doing internally again. We just care about what goes in and out. Now we're going to get into a special problem in a second that's going to challenge this idea, but I will show you how to deal with such situations. All right, so let's keep stepping. We step over again and then inspect use error boundary, and it's just an object that contains a bunch of functions, including reset, is reset, and clear reset. We don't care about any of this. We don't care about how use query error reset boundary works. We just care about what it produces for now. Then stepping over one more time, we have a variable here called defaulted options, which is storing the value that is returned when we call default query options on client. Now, this is the only thing this is where we actually need to pay a bit more attention. We already know rather, that client is a query client object, which means, or let's just call it a class for now, which means it has methods and properties. And one of those methods is default query options. Let's see what goes into this method. If we inspect options, we can see that it's just a simple argument that we passed in when we called use query. The simple options we passed in when we called use query, which is the query key and the query function. Now, if we take a look at what defaulted options is, you can see that this is where things start to get interesting. This function takes a plain, simple option object and gives us an enhanced one, we still have our query key, we still have our query function at the end, but you can see that it first of all flags this new object as defaulted, then it gives us a query hash. We don't know what that is, we don't care about that yet, but sometime in future when we keep inspecting this code base, we'll figure it out. We know what the refetch, we know that it attaches a refetch on connect property, sets it to true, and then it sets a throw on error property to false. These are just default values, but the most important thing is that we know that this function takes our option and adds a few default properties and values to that object, or it takes our option object and adds a few properties to that object. Perfect. We're going to skip these 2 lines because they are experimental. These are just features that the TanStack Query team is still considering. Let's not worry ourselves with that. What's going to happen next is that we're going to see what this line does. We can see that it's using is restoring value again, which is false. If you remember the last time we checked what is restoring true, gives us it's false. Then it's setting a defaulted option property to either optimistic or is restoring based on this value. We know it's not restoring, even though we don't know what is we don't know why is restoring exists. That is what happens when we test is restoring in isolation, but we know at least what it's doing, which is that it's giving us a false value, and that's why we're setting the property optimistic result on the option to optimistic. So if we inspect defaulted option one more time, if we expand this query, you can see okay, I think we need to actually skip this part. Yeah, if we inspect that one more time, you can see that optimistic result is now optimistic. It sets a new value and a new property. Now remember when I told you we're going to run into a situation that is going to challenge the input output idea? Now we're here. There's no output for this function, so how do we debug this function? How do we understand what is going to happen when we execute this function? Well, we can't tell from looking at the function or looking at the data that comes out of the function, but the only thing we should care about is that this function should potentially be doing 2 things. 1, mutating the data being passed to it, which is a bad practice, and I don't think that's what's happening here. Or secondly, it's doing some checks and making sure some things are set up. If those things are not set up, it will either throw an error or set them up again, which would end up mutating this function or mutating this value. But if that's the case, what we want to do is just ensure that the value being passed into these 3 functions go in and out unharmed. So if we pass defaulted options into ensure suspense timers, if I skip over this function and inspect defaulted option one more time, if I expand the value, we should be able to compare it with the previous value. You can see that query key is still query key's value, defaulted is still true, query hash is still query 1, refetch on reconnect is still true, throw on error is still false, optimistic result is still optimistic, and query function is still query function. That's the only thing we need to check to make sure that this function doesn't do anything funny. What we then do later is to come back and find these dependencies in this function, including this one, test it in isolation to understand what it does. Brilliant. Now let's move on. If we step over this function one more time, we can inspect defaulted option again and error reset boundary. We don't need to do all of this because I already did this, and I know that these 3 functions aren't mutating their data, so we can just move on. Perfect. Now the next step is to call the get function on the query cache that is returned from the client, and we pass it the query hash. And this is just going to check if this is a new cache entry or if there's a cache that already exists with the same query hash. And you can definitely expect this to be false when we skip over or step over and then inspect this value. You can see that it's true, which means that this is the first time this item is going to be stored, or the response from this query function is going to be stored in this cache. Perfect. Now with our client and our defaulted options, we're going to create a new observer, and we're going to pass both of these data to the observer, both the client and the defaulted option, and we're going to wrap all of that in use state. The reason why we're doing this is because whenever these components renders, we want to make sure that the state, that React tracks the state of this observer, the return value of the observer. And what's going to then happen is that, again, we're not going to care about what observer does, but you can start getting clues on the fact that this project is heavily using the observer pattern. But back to the point, this is going to return an observer, and then what we're going to do is use the observer to get the result. So if we skip over and inspect the value of result, which is calling observer, which we get from React.useState, which is the return value of this constructor. If we call .getOptimisticResult and pass it the options, we can inspect the result and see what we get from that, and see what we get when we actually inspect these values. And you can see that this is similar. If you've ever used React Query, you should be familiar with this output. Let me just make this a little bigger. Yep, you should be familiar with this output. You can see the status, the fetch status, and the data, which is still undefined because this is still pending. But the most important thing here is that we've just gone from not knowing how useQuery works to the point where we actually have an output from useQuery. And this is what I want to take out from this video, is the fact that now you understand how useQuery works. You can basically, let's say, go to the useQuery client, which is the first dependency we experienced here, open it, find the test that covers this function, and then run that test and walk through this function as well. And that is how you read a code base with AI. I hope you found this video useful. It became longer than I expected, but I still hope it was useful to you. Thank you for watching this video, and I will see you in the next one. Bye.